Hey data enthusiast, welcome back to Guide Coaching, the go-to channel for all things data-driven. I welcome you to another exciting episode of our Python programming series. Are you ready to dive into the world of numerical computing and revolutionize your data analysis skills? Today we are exploring the powerhouse of Python libraries, that is NumPy. Discover why NumPy is the go-to choice for handling large datasets, performing complex mathematical operations, and accelerating code execution. But before we jump into NumPy, let's clarify some basic fundamental concepts: list, arrays, and matrices. Okay, what are the matrix, what is list, and what is array? We are going to demystify all these three concepts in this tutorial. Understanding these data structure is crucial for harnessing the full power of NumPy in our Python programming projects. So grab your coding gear and let's get embark on this exciting journey to master NumPy. In case you have not subscribed, please do subscribe. By subscribing, you are not just joining a family passionate about success, you are joining a family that is leveraging the data for success and accessing it to go to a next level. Okay, so let's get started with today's topic. So there are three topics which we are going to cover today. What is NumPy? We are going to see what is NumPy, why it is so important in Python, and the next thing is what is list, arrays, and matrix. Okay, we are going to see all these three concepts. Let's get started with the advantages first. What is NumPy? So NumPy is basically is a numerical Python. Okay, it helps to use whenever you are using data, specifically data of numbers. At that time you will be, it is recommended that you must use NumPys. Okay, there are certain advantages of NumPy. NumPy is a basically Python library used for working with arrays. Whenever you want to work with arrays, you can use NumPy and use the arrays. Okay, then the second is concept is it is providing multi-dimensional array objects. So whenever you have multi-dimensional objects, or when you have multi-dimensional arrays, at that time you can use NumPy. The next important factor, it is much faster than your list. So you can store data in list as well, and you can store numbers in your array as well. Specifically arrays are used for numbers. So whenever you are dealing with numbers, it is advised that because it is, you can see, it is 50 times more faster than your normal list. So obviously we should use NumPy and arrays. Okay, NumPy can be one dimensional, two dimensional, zero dimensional arrays. Okay, then NumPy consumed very less memory and very efficient, so that is the reason we use it. And the next is NumPy package or libraries for scientific computing in Python. So whenever you are working as a data scientist, at that time NumPy is your go-to tool to use your data for analysis. Okay, now let's quickly see what is one dimensional, two dimensional, and three dimensional arrays. So this is your first dimension, one dimensional array, this is your two dimensional array, and this is your three dimensional array. Now we will see how how to use it. Okay, so there are two steps. The first is the installation. Once you install it using pip command, so pip install NumPy on your Jupyter notebook. Once it is done, it will be you will be able to use it. And then the second is importing. If you have installed it, you need to import it onto your current project, onto your current notebook, Jupyter notebook, and then you can use it. Okay, now let's see what is the difference between a list, array, and a matrix. So let's start with the list. So basically list will will start with an array. So array will have indexing and the values inside it, the numbers. Then we have the list. So in list we have indexing again, and then we will have the numbers or the characters, and then we have matrix. So here matrix is 3 by 3, where this part holds the index as 0 0 0 1 0 2. Then this part will hold 1 0 1 2 likewise. Okay, so this is how the indexing part is. Once you understand the indexing, it will be very easy for you to track the elements and see it how they are working. So let's quickly jump on to the practical window and let's see how a list and a list and array will be differed. So first of all, I'll show you how list will look like. So this is how you will create a list where you will write 1 2 3 4 and 5. Okay, and once I print it, okay, so print your list, so it will give me the values as 1 2 3 4 5. Now what I will do, I will import NumPy. So I need to import it whenever I need to use it, np, and then over here what I will write, I will write my ARY is equals to np dot array. Remember the syntax, okay, ARRAY, and then I will be writing inside it, I will be writing as 1 comma 2 comma 3 comma 4 comma 5. Okay, and then I'll close it, and then I'll go to a next line, and then I'll write print, and then I will write my ARY. Okay, once I do that, now see the difference how it is returning. So my array is returning without comma, and this is writing with comma. Okay, now if I want to see the type of it, I can simply write print, and then I will write type, and then if I write ARY inside it, it will give me the type of it. So it is giving me NumPy, and if I copy it's the same thing over here and paste it over. Okay, just give me a second, Control Z. Okay, I'll just copy this, and then I'll paste it over here, and I'll change this to list, so it will be of list type. Okay, if I execute it, see, this is the list and this is your NumPy. Okay, now here if I want to change the data type, like if I want to change it to 64-bit, then I will write int 64 over here, and then simply I will write ARY, and then I'll do a control execute. So it will show me that okay, it is 64. If I want to change it to 34, it is not going to see a show because by default it is 34. If I want to change it to less than that, I can do that as well. You can change to float as well. Okay, so this is the one part. Now if I want to traverse, how you will traverse through it. So if I want to traverse over here, I'll just delete this part, and I'll if I want to traverse over here, so what I will write ARY, if I write like this, okay, and if I execute it, it is going to give me the 0th and first index. So this is the value it is going to give. Now if I execute the same over here, that is print, and if I write list over here, and then I will write over like this, so it is going to give me the value as this. Okay, so this is again going to be the same, the traversing. Okay, now if I want to change it, so this is the traversing part. Now if I want to see dot ndim, okay, so this is the value n dimensional. So this is ndim is used for you understanding how many dimensions are over here. Okay, so if I want to use a 2-dimensional or 3-dimensional arrays, I'll simply write it like this over here, and then I will write 0 dot n dimensional, and then I will, if I execute it, so it is giving me 0 is n dimensional, and if I copy this, I paste it multiple times over here, and I'll just change it from 0 to 1, 1 to 2, and likewise. So if I copy this and if I paste it over here, and then n dimensional, and if I execute it, so this is how it is going to show me the dimensions of each and every. Okay, now if I delete this and if I execute it, So this basically it is going to show me the dimensions of my array, how many dimensional array I have. Okay, now the next concept comes in, that is, what if I want to create a range of through it. So for creating a range, you will be simply using n range, okay, over here. So like I'll delete this part, and okay, I'll just delete this part over here, and then I will be creating ARY is equals to np dot a range. Okay, here it will take three parameters, 1 comma 5 comma 10. So it is going to give me 10 elements. If I execute it, so it a range, okay, a range. Okay, so this is going to basically give me the range of it. Okay, so if I write like this, if I write like this over here, and if I do a temp, so basically it will going to give me a range of from 0 to 9 elements it will be going to create, and it will be going to store in it. Okay, if I want to access the second index element, I can do that as well. Okay, if I want to access the 0th index element, I can do this. So this is how you can access it using it, and you can create a range of it. Now we have one more function, that is linspace. We call it linspace. Okay, so I will just copy it, linspace. Now what is linspace? It is going to give a linear space in between. Okay, so here if I write it like this, it is going to give me three values between 1 to 5. Okay, I'll just need to l space. Okay, I'll just need to write like this, and it will going to give me three values. Okay, if I want 5 values, or if I want 5 equal distance values, then it will going to give me 1 2 3 4 5. If I want 10 values, so it is going to give me values which are separated, which are equally on a equal distance with each other. So this is going to be on equal distance with this one, and this is going to be on equal distance of this one. So it is going to basically create me for a sample data, so sample data set for me to analyze, and to how it is going to be used, we are going to see that. Then if we want to create a zeros and an array or a matrix using it, we can write like np dot zeros, and then over here if I execute it temp, okay, I'll write like this, and I will write temp. So it will basically create me an index of a matrix of 5 by 5 with all the 0 elements. Okay, we can add elements over the index over here, and we can get the values of it. Okay, now we can create an empty index as well. Over here it will be similar to this. Okay, so if I write it like this over here, and if I just copy it, so it will be similar to it. We can create an empty index over here. Okay, and I will write empty, and if I execute it, it is going to give me the values like this. Now if I want to access this, see, this is my 2 by 2 index. Most of the time we will be creating a 2 by 2 matrix. Okay, so if I have like a matrix like this, and if I want to access the element which is, so see, this is on 0th index, 0 by 0. Okay, 0 row and 0 column. So this is your row, so it will be having a row values first, and then it will have the column values. So first it starts with 0 0, the row will be 0th row, this will be the first row. Okay, then the column, this will be the 0th column, this will be the first column. Okay, these two values will come in one column, these two values will come in one column. So if I want to access the element on 0 0 index, I'll write 0 0. Okay, so what value it will give me? It will going to give me 1. Okay, this is my 0 0 index. Now if I want to access my last element, so this is on second, that is first row, but on the 0th index. So this will be my row will be this. Okay, and this is going to be on my 1 2 0 1 2. So this is going to be over here. So see, this is going to be 0 1 and 2. So this is going to be the sixth value. Okay, this is how you can use your NumPy. There are some more examples which we are going to see into our coming tutorials, but first just understand these things. These are going to be very important. Now there are small things which I would like to cover over here as well. So I'll just delete this and I'll just copy it over here, and we'll see them one by one. So I'll see first shape. Okay, so I'll just delete this dot shape. Okay, and if I execute it, so it is a 2 by 4 matrix. Okay, now if I write it over here dot shape, so it is going to tell me that it will holds 2 rows and 4 columns. Okay, rows and columns. Okay, shape. Okay, and then if I execute it 5 by 5. Okay, so it is going to hold the values. Because why? Because here we have temp, and if I execute it, just give me a second, if I execute it, it is going to give 5 by 5 matrix. So if I want to know how many values are there, so for this, if I if I am going to use it for this, okay, over here, and if I write 1 dot shape, so it is going to give me 5. Okay, why? Because here we have 5 values. Okay, that is how it is going to work. Now if I want to see the data type, so we have seen like how we can see one dot d type. Okay, and then we execute, so data type is by 32. Okay, that is how we can do it. Then we have one more type, that is size. So to check out the size, we will be writing over here the size, and we can get the size of it. Okay. So this is how we can get it. So let's quickly revise what all things we have learned. So whenever we are creating an array, we will be using NumPy in Python, because it gives a lot of inbuilt functions to access it using it. Then if I want to change the data type, we can use np.int and we can give the int 64 12 int 64 13 32 and 64, whatever we want. Then if we want to know the shape of it, that 2 by 2 3 by 3 4 by 4, how many columns and rows are there, so we can use shape. D type is used for identifying data type. Then size is used to identify the size. A range is used to get a range from a particular number. Okay, we have seen that as well. And then we can create an index with we can create a linear space, and we can create a matrix using this. So this is the starting, this is the ending of the number, and these are the number of elements we want into a array. Then we can have zeros. Okay, we can create a zeros index with 5 by 5 matrix. We can have 2 by 4 matrix with empty values. Okay, we can insert the values inside it. Then we can have a 0 dimensional, 1 dimensional, 2 dimensional, 4 dimensional, and as many as we want, but most of the time we will be using 2-dimensional arrays. Okay, then ndim is your n dimensional. Okay, how many dimensions are there, so you can get those dimensions. And then we can access the values on the basis the same way we access the values on a list. We give the index, the same way we can use it for array as well, and we can get the elements. Okay, That's all. I think we have covered all the points which I wanted to. Okay, if you have learned something, if you enjoyed listening this tutorial, if you learned something new, you can give me a thumbs up and subscribe to my channel. And if you have any questions, any queries, or any doubts regarding the topic we have covered today, you can write me a comment and we will be discussing it into our next session. That's all for today. Thank you so much, and we are closing the call. Bye.